Hello and welcome to Phizzle's Big Five webinar. My name is Cecily Carter and I am the Senior Director of Go-to-Market Operations, and I will be your host today. This is a very important moment at Phizzle, and I am super excited to share it with all of you. Our platform, EdgeMaker, now remotely operates 5 mission-critical drug production instruments, creating the only production use case of a software-defined architecture in the pharmaceutical industry. During today's webinar, our industry expert will talk about each of those instruments. Phizzle's Chief Technical Officer will give you an overview on how our software-defined architecture works and how it integrates with the IT/OT ecosystem. Our Chief Innovation Officer will perform a live demo, and Ben Davis, our CEO, will explain the importance of this market and how we are able to guarantee operational cost savings. Our customers are telling us the only path to data integrity is through a software-defined architecture. So let's get started. In our first segment, Parker Wims, Phizzle's product evangelist, will dive deeply into the Big Five instruments with Phizzle's industry advisor, Lena Wu. Parker?
Thank you, Cess, for that introduction. I'm here with Lena Wu, strategic advisor to Phizzle and a serial entrepreneur in the biomanufacturing space. Her most recent company, Intabio, was acquired by SciEx selling analytical instruments. So kind of the perfect person to have this discussion with. Welcome, Lena.
Thanks, Parker. Super excited about our conversation today.
Me too. You are the perfect person to talk to about this. So to start off, could you just maybe briefly describe what these instruments actually are and what they do?
Sure. So there are currently 5 instruments that Phizzle connects to or deploys its software on. And these instruments are essentially the everyday workhorses of the drug development, drug manufacturing process. So while their functions are pretty simple, meaning that they're not really sophisticated or complex instruments, what each of these instruments do is really absolutely critical, particularly for drug manufacturing when you take them all together. So the 5 different instruments are air particle counters. So this instrument basically monitors the quality of the air in the manufacturing site. Is it clean? Because if you got dirty air, then that'll get into your drug, and then you're not making a safe drug. Balances. So balances are responsible for weighing and measuring the amount of a given chemical. So those are really important. pH meters measures the pH of a solution. That's really important because drugs have to work in a biological context. And so if you have something that's super acidic or super basic, it's not going to work. It has to be within a certain range for biology, which is typically close to 7.0, pH 7.0. Hot plate stirrers. So hot plate stirrers are really just there to help mix and make solutions. They mix solutions and they heat solutions that are made up of complex, many different chemicals. And then finally, we have the zetasizers. So those are a little bit more specialized. They basically measure the size or the amount of particles in solution. So essentially a quality control measure in drug manufacturing.
Okay, so we've kind of got a buffet table of options. Thank you for that's a great short description there. And why are these instruments themselves so important to the biomanufacturing and pharma space?
Yeah, so it's actually really important to understand because, as I said, they're very simple, but just because they're simple doesn't mean that they're not important. So let me use the analogy of sort of a bakery being a manufacturing site, similar to a drug manufacturing. So if you're making a cake or making a drug, you need to make sure you have a clean environment, right? Dirty environment, dirty air, all that dust, or maybe it's some sort of pathogen, a bacteria or something in the air that gets into your drug. So that's bad, obviously. Gets in your cake, that's bad. So you need a clean environment. Balances are kind of like your measuring cups and spoons. I mean, you can't make a cake without measuring very specifically, the amount of the different chemicals that go into either your drug, or in the case of your cake, if you get the baking soda off or the baking powder, your cake doesn't rise. And then the hot plate stirrers are literally your mixing spoons, your mixer, and the heat for, say, like dissolving sugar or something like that in your cake. And then finally, the pH meter is really, as I said, how much acid or how basic your solution is. That is really taking the place of our taste buds. That's how we actually determine acidity in cooking. You can't go around and taste these chemical solutions, obviously, in the drug manufacturing space. So that gives you a sense of how basic they are. They really are the underpinnings of the whole process, the whole drug manufacturing process.
So the way you see this big five is as sort of the everyday building blocks or workhorses. I like that.
Absolutely.
So,
I mean, every lab has them, and every lab has multiple, multiple numbers of each of these types of instruments. They're just very common.
yeah. So if you're in the space or if you're a lab technician, you're super comfortable seeing these in different makes and models.
Oh, absolutely. I mean, if you're a even as early as being an undergrad in a chemistry lab or biology lab, you will see these instruments.
Yeah. So I guess going off that point, why is integrating EdgeMaker software on those instruments that have kind of been around for a while? Why is that a big deal for this space?
Yeah, so that's a really great question, and that's really the heart of the value proposition for in terms of what Phizzle is bringing to the drug manufacturing industry. So I'm just going to back up and explain a couple of the context that of the industry. So there are two really important goals that everybody in the drug manufacturing industry is focused on right now. One is efficiency, and the other is data integrity. And those two sort of pillars of drug manufacturing are really important because, as people know, efficiency is is a very high priority, and it's about getting more production out of existing time or existing equipment. So that's become very important, particularly after the pandemic. We need to make drugs faster, and currently the US doesn't have enough drug manufacturing capacity. So, we could build more manufacturing sites, but those are very expensive and they take a long time to build. So short-term solution is focus on efficiency. The other term, data integrity, means the recording of all the scientific data has to be both accurate and complete. And this is particularly important for pharma companies because when they go and ask the FDA approval for their drug, in order for them to commercially launch, the FDA essentially reviews the pharma company's entire drug development and drug manufacturing process. They review this whole huge report. And they're asking the FDA for approval so they can commercially launch the drug. And not only does the FDA review the report for, yes, is the drug safe? Does it work well? But they're also making sure that the data has been recorded very accurately in a way that's accurate and according to the standard operating procedure. So is it recorded in the right way? And that's called data integrity. So how does EdgeMaker software, help these two or address these or achieve these two really important goals? Well, for that, you need to understand that all of these big five instruments are largely very manual in their operation and also very manual in terms of recording the data. So we know that these instruments are really the workhorses of any manufacturing process or any drug development process. And the problem is that if you have a lot of manual operation, then it's not very efficient. And then secondly, if there's a lot of manual data recording, people tend to make mistakes. So these are prone to errors. And these errors turn out to be the Achilles heel for data integrity. So there was a study published about a year ago that looked at what is the main reason for companies getting warning letters from the FDA. And these warning letters are basically letters that the FDA issues to a drug manufacturer once it has reviewed the report and said, oh, you know what? You didn't follow the rules for recording data. So essentially there are issues with data integrity. 80% of those warning letters were due to data integrity problems. So that's where EdgeMaker is providing a huge amount of value by automating the operation and automating the data recording. They are addressing the efficiency, providing much more efficiency, and they're reducing the amount of data integrity issues, which will overall have an impact in terms of reducing the number of warning letters. And these warning letters are very serious issues because basically a pharma company is prevented or has to halt and address the issues in the warning letters before they can go and commercialize their drug.
Thank you, Parker. I love that Lena referred to these mission critical instruments as the everyday workhorses of pharmaceutical manufacturing. And as a result of integrating our software into these instruments, Phizzle is providing both data integrity at the strategic level and efficiency to the bottom line. Okay, now let's jump into our next segment where we will dive a little deeper into our architecture with Ron Ricci, Phizzle's board chair, who was talking with our chief technical officer, Ryan Brady, about the importance of a software-defined architecture. Ron?
Thanks, Tess. I really enjoy learning from Lena and hearing about this industry. It's still hard to believe to me that these big five that we're talking about today are not digitized yet, especially considering, as Lena said, they're the everyday workhorses of pharma manufacturing. I think that that's what makes it exciting today, we're announcing, the support for these five instruments. And I think your question is totally the right direction to go into, which is to really peel back the onion a bit on our differentiation, because it does kind of beg the question, what's taken so long for these big five instruments to become part of the modern digital ecosystem? And so what I really want to do is to start at the architectural level, because that's really where the differentiation of what we're doing starts. And there's no better place and person to hear that from than Ryan Brady, our Chief Technology Officer, who's currently in our Denver lab. So Ryan, maybe what you can do for our audience is at the highest level, define our architecture, and then let everyone know exactly how that architecture fits within the IT, OT ecosystem of our customers.
So if you take an instrument, we usually, not always, but usually pair that with a gateway. That gateway will then connect back to our system, and which is really just a collection of microservices. And that runs inside of Kubernetes. And since it's in Kubernetes, you can deploy that either to the cloud or you can do it on-prem. And with our microservices architecture, it's very straightforward to integrate with things like Active Directory, which most people want to do. We can also integrate with like a LIMS system or MES. So those integrations are pretty key for a lot of our customers.
Thanks, Ryan. Because we're able to digitize this data on these devices, what you described is so important to be able to get that data from our software-defined architecture through these systems that our customers use to manage the data in order to turn it into productivity and value. So that Active Directory integration, the LIMS systems integration, those are critical parts of the pharma ecosystem to deliver value to customers. But of course, we have to capture that value first. And that really starts with these instruments. And so I know this architecture is going to let customers do things that they've never been able to do before, like maybe work much better with all the different collections of instruments they have to capture that data. Why don't you dive in a little bit more about what makes us different?
A big differentiator for us is that we are multi-vendor. So as you can see, like in the example of these particle counters, there's 4 different particle counters from 4 different manufacturers. So when you connect these to our system, you can use them all as if they were the same instrument. It doesn't really matter which brand they are. It doesn't matter where they come from. They're operated the same. That's huge for simplifying SOPs, for quickly transitioning to different instruments. It's a huge benefit, and the automation that you get from that is a huge labor savings.
Now, Ryan, one of the core principles of a microservices software-defined architecture is automation. And I've heard you use that word a couple of times today, and also describe some of the potential value of automation to our customers. We know one of the ways with which that value of automation is delivered to customers is through the ability to remotely operate these devices, which has tremendous cost labor savings for our customers. Could you maybe just take a second to share exactly how easy it is to remotely operate a device and maybe a pH meter and give everyone a sense of just how the software does that?
We focus in three primary areas. We're actually pulling data from the instrument. That's the first. The second is data integrity. That's huge. And then automation. So actually automating the instruments is a big is the end result most people are looking for. But let's actually do something. I'm going to take this pH meter that's behind me right here, and then let's just log into the system and run a sample, and you can kind of see how a quick example of how you might use our system. I've already logged in, and you can see these instrument types. We'll just do the pH meter for now, and we're just going to do this very quick because we can spend a lot of time here. But anyway, I selected an instrument. I'm looking at its history. It's clearly good enough for what I want to use it for today, but that's an opportunity, if it's not what you're looking for, to pick a different one. So there's a lot of methods on this because it's a test instrument. So I'm just going to say demo is our sample ID and hit start. Now, if I switch my camera to the instrument behind me, I can actually show you the screen of the instrument. So in this scenario, the instrument's completely locked out, and we're operating it completely remotely. So coming back to our UI here, I can now, it's completed. We see the 5.17 pH. I can hit complete. There's an opportunity to make a comment. There's a lot more information that's stored. I can confirm it. And that's it. That's a pretty quick, basic example of how you would use our system. Very straightforward. We can release this instrument and let somebody else use it, or we can use it again later.
Thanks, Ryan, for that high-level architectural overview and quick description of our differentiation. What really separates us from the pack is the fact that we are the only software-defined architecture in a production use case with a Fortune 75 pharma manufacturer. And of course, what is really the biggest proof point of that is our ability to support these big 5 workhorses of pharma manufacturing, not just the 5 categories of instruments, but the fact that we can do it across multiple vendors of instruments, as you saw from Ryan. But I think we got to peel the onion, Sess, even a little bit deeper and start to see some of these instruments in real live action right now. So what I'd like to do is turn this back over to Parker, who's with Mike Patrick, our Chief Innovation Officer. And between the two of them, we're actually going to see this live and in action.
Hello, my name is Michael Patrick, Chief Innovation Officer at Phizzle. I'm going to be showing you a demo today controlling one of our devices in our Denver lab. Now, currently I'm located in the Atlanta area. However, doesn't matter. You can be anywhere in the world using our platform to control devices anywhere else in the world. Here we have an entry into our platform through our user interface. We simply sign in and are immediately presented with the big 5 that were discussed earlier: particle counter, balance, pH meter, zetasizer, and hot plate stirrer. So I'm going to select particle counter for our demo. And here we have a list of samples that are scheduled to be run and that have been run already. I'm going to select the second sample to run. And now the sample, it's scheduled to run. However, it's up to the operator to choose what equipment they're going to run it on. This entire process that I'm going through currently is mirrors and is an exact duplicate of an existing standard operating procedure at a pharmaceutical manufacturer that was duplicated through this user interface. We're now going to choose the equipment, and part of that SOP was to verify that the sample, that the equipment was properly prepared. All this information that I'm that I'm filling out here and all these steps that I'm going through are all put into an audit log for verification that this process was followed to the T. Now we have a list of devices that are available. This particular one is in our lab in Denver. Again, I'm controlling this from the Atlanta area. I'm going to select that device and then go to the next step, which is a confirmation to the operator that this is the device you want to use. For our sample today, we're going to be using this device, which is called a MET1. I'm going to confirm that now. And this then shows us a summary of the equipment, that it's connected, it's ready to go, and it's all set. At this point, I can start the sample. This shows me the sample settings. This information is pulled directly from the laboratory information management system on a sample that has been scheduled to run. The volume, delay, and units are fixed at 1, 5, and cubic feet respectively. The only thing the operator pulls in here is the status of the room. Once the sample, this information is confirmed, our system now communicates directly to the device and begins the sample. And this particular one will run for approximately 1 minute, because it's a 1 cubic foot sample, and the flow rate on this device, 28.3 liters per minute. That is, of course, equal to 1 cubic foot. Now, taking a quick look at the device that we're running, we see that there's paper tape on the device. The current or the past use for this particular device was that an operator would work the front panel, run the sample, take the paper tape, put that in the report, and that manually gets entered into the LIMS system. That paper tape is no longer used. Our data is taken directly from the device electronically, put into our database, and then pushed automatically into the laboratory information management system. This ensures data integrity. There's no gap, there's no loss of data, and it simplifies the workflow and overall ease of use for the operator and the laboratory environment in general. So our operation just finished. The data was automatically put into our system. We then, operator then confirms the results. We see this particular one had a relatively high particle count. Again, this is in a lab. And we see that there's various other information about the sample. We collect everything. And again, this all goes into the database, and it's all linked to the operator that was actually running it. So there's a place here for the operator to put in comments here. I have really none at this time. We now confirm the results. This was a success. And then now to finish the sample, we simply click the finish button. And again, because everything is audited and everything tracks an existing standard operating procedure, these were steps in this particular standard operating procedure. No comment here. And at this point, the credentials need to be re-entered that were put into the login to verify that it's the same operator who's finishing the sample. So once that credential information is re-entered and submitted, we successfully finished the sample, and that's it. Now that data was collected, the device was reset, it's ready to run another sample. That information was pushed into the laboratory information system as well as stored in our database. So that concludes our very quick demo of our platform. Again, the highlights here were two things of prime importance. That's the data integrity. No more paper tape. The device is controlled explicitly through credentialed, audited activity by the operator through our platform, and also the duplication and exact compliance with the existing standard operating procedure, with every single step audited along the way into our database. Well, thank you very much for the time. That concludes this portion of the video.
Thank you, Mike. It's always great to see the instruments in action. I do want to reinforce to all of you that Phizzle is in the proof of value position in the market, as our EdgeMaker platform is already proven in real-world customer environments. So if anyone would like to sign up to not only see a demo, but to take a test drive, meaning operate any of these instruments live, make sure to sign up at our website, Phizzle.com, and select the tab that says Request a Demo. In our final segment, Ira Shapiro, Phizzle investor, co-founder, and influencer, discusses the market we operate in with CEO Ben Davis. Ira.
Thanks, Sess. Hey, Ben, I have a few questions from the point of view of an investor. Can you describe the market that Phizzle's in, like how big it is and why it's so important right now?
Sure, Ira. We are in the business of digitally transforming the pharmaceutical manufacturing industry. At Phizzle, we believe this might be the last major industry to be truly disrupted by the internet. The discovery and production of drugs has been mostly manual and still involves paper. Yes, scientific instruments have significantly advanced, but they still need people to operate them, and the operating software behind these instruments are not nearly as advanced as what they can do scientifically. The life sciences industry, some would argue, is a top 3 industry in terms of total addressable market and even value. We believe it's the most important because our lives depend on drugs and vaccines to keep us healthy. It is important now more than ever to help drug manufacturers reduce their costs so that our costs as consumers go down and every human being can afford to live a long and healthy life.
Wow, that's terrific. Well, I have another question. Phizzle says, and that I read that Phizzle says that it guarantees operational cost savings. How can the company actually guarantee these savings? That's a big claim.
It is. Our software automates the operation of multi-vendor and multi-types of scientific instruments. By reducing the amount of people needed to operate these instruments and manually ensure data integrity, the operational cost goes down significantly. We have proven this already with the production of one of the world's best-selling drugs, and will continue to add more instruments to our portfolio for even more cost savings.
Well, it sounds terrific. I mean, this seems like a revolution for the drug manufacturing industry.
We believe it is, and it's just the beginning.
Great. Well, thanks, Ben.
Thank you, Ira.
Revolutionary indeed. We just received the following question online. Now that we are collecting this data, what is the impact on AI? Great question. What I can say about this is one of the issues holding back operational efficiency in pharma labs and manufacturing is the lack of digital data. Behind the scenes, our architecture is harmonizing the data into a common format, which is the necessary first stage of building a curated data model for AI applications. I think we should turn to Lena, our advisor, for her insight and perspective. Lena?
Yeah, so huge focus on AI right now. And AI is fundamentally about being able to use tools like machine learning to gather and look at data, analyze data, and gather new insights. And if you can't, so in order for AI to work, it's got to have a data set. It's got to have access to a data set. So let's go back to our big 5 instruments that are largely manually operated and where the data is recorded manually. So if you're writing down your data, all your measurements on a piece of paper, that's not digital. The computer doesn't have access to that data. So right now, a lot of measurements are written down manually, and then somebody has to type that written down thing into their computer, their electronic notebook, and then it's accessible to AI. So then you can mine the data for all sorts of insights and do analysis on it. But if it never gets into that central database, if it never gets into that computer, or if maybe the human being who is typing it gets distracted for a second and types in the wrong number, those are both problems for AI. So you can't deploy, you can't use AI if you don't have good data and access to that data. So really the big value for AI in terms of what does EdgeMaker do, it brings in all that data from instruments that before AI didn't have access to. So it's a hugely important function of EdgeMaker software. And not only is EdgeMaker bringing the data into a database where it can be accessible for AI, but one of the huge strengths of or advantages of EdgeMaker is that it works across many different instruments, many different brands, many different models. And that's a powerful tool because, you know, any given lab will have dozens or maybe even hundreds of different instruments. And most of those don't talk to each other today, right? Because they're bought from different companies, different brands. So EdgeMaker is providing this software architecture that connects everything that's being used in the lab and is a way to access and bring together all of the data so that AI can be applied.
Thank you, Lena. Well, we have reached the conclusion of our program. Thank you all so much for tuning in and learning all about Phizzle's Big Five. If you do have a question that may not have been answered, please feel free to email us at info@phizzle.com. Additionally, if you would like to request a demo, if you follow this QR code, it will take you directly to the form. If you fill it out, one of our engineers will get back to you and will schedule a time. Thank you all so much.